You good, Alex?
Yeah.
Let's start. Actually, typically when you win a lottery prize, they pay it out over 20 years if it's a big prize. And so you can choose to have it paid out over 20 years, or you can take a smaller amount up front. Why might you take the smaller amount up front? Why wouldn't you want the full amount paid over 20 years? Yeah? Well, like if you win this when you're 70, you might say, I'm not sure I'm going to make it for 20 years. I want the money now, even though it's a smaller amount. If you win it when you're 20, you might say, oh, heck yeah, the next 20 years, I don't have to work. I can pursue other pursuits. I can get a degree in something that I enjoy. I can travel. I prefer the payments spread out. Really depends. So this individual, Mavis, she chose to receive a single payment of $480.5 million. Now, there would have still been taxes. Oh, no. Never mind. She won this in Florida. No taxes. If she had won this in a different state, if she lived in a different state, she probably would have paid about $200 million of that in taxes, maybe more. But she managed to avoid taxes, so there's a win. What if she spent $10 per minute? I think what I'm going to do again here, Ethan, is I'm going to take this amount, $480.5 million. I'm going to divide it by 10 to find how many minutes this is. So let's do that. 480.5, and million is 10 to the 6th. You can add all the zeros if you want to, but I've learned that million is mega from the metric prefix, and that's 10 to the 6th, and that's less writing. Divided by 10. I pull out my trusty calculator, because by now everyone has one. And I get 4805. I probably could have done this in my head because it's all tens. I get 4805 and 4 zeros. That's how many minutes it would take her to spend the money. What do I want to convert minutes into? Years eventually, but you're right. What am I going to, actually, I think I'd first convert it into hours and then convert hours into, and then convert days into. I've got my chain. First thing, write down what they gave me. 480. I wonder if she spends money at the rate of $10 every minute. Can she spend this in her lifetime? Maddie, where am I going to want minutes in the next fraction? On the? Yep. And I can go hours, and I know 1 hour. The 60 goes on the bottom this time. I'm going to be dividing. And this is what tells you whether you divide or multiply. I told you one of the things kids always ask me, Mr. Dueck, do I times the 60 or divide the 60? Caleb, the fraction will tell you if you set it up right. Take some practice to get this method down pat, but it's really a nice one to have in your back pocket. So now I want hours to cancel days, and it's 1 day is 24 hours. And days, and remember I told you last day that the proper abbreviation for year is a capital or lowercase a for annually, but if you write a Y, I'll figure it out. It's just technically that's yards. How many years is how many days? 1 year is how many days? 365. Did I talk about leap years last class? No? Okay, so 1 calendar year is exactly 365 days. 1 solar year isn't exactly 365 days. It's what? 365 point what? Anybody know? So Iman, some people will say 0.25, 365 and a quarter, because they say we have a leap year every 4 years, and that's what takes care of that. It's actually 0.24 something, 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 because you have a leap year every 4 years, unless, does anybody know the unless? If the year ends in 2 zeros, even though that would be a 4th year, you don't have a leap year. So 1800 was not a leap year. 1900 was not a leap year. Unless the year ends in 3 zeros, then you do have a leap year. So the year 2000 although it ended in 2 zeros, not a leap year. It ended in 3 zeros. It was a leap year. And Nick, that takes care of everything except I think somewhere in the year 8000 we have to make one more adjustment. So if you're around then, there is one more adjustment we are going to have to make. But those take care of the fact that our calendar doesn't quite match the solar year. You'll get a lot of nerd trivia in this class. That's not on the test. That's just purely because I'm a nerd and I read things. Anybody crunch the numbers yet? Can she spend this in her lifetime? It's going to be this number, which thankfully is still stored on my calculator. I think if you have a good calculator, most of you find that if you press a key, like divided by, it'll fill in the answer symbol for you right away. And you should find where your answer button is. For most of you, it's either right next to your equal sign, or second function right next to your equal sign, or second function equal sign. But that's well worth figuring out, Austin, where that is. It's a huge time saver. It's more accurate. It's less typing. It reduces errors. It's a triple win. So we'll use that very often. Divided by 60, divided by 24, divided by 365. Can she spend this in her lifetime? Depending on how old she is when she won. But still, probably not. That's a lot of money. What's Jeff Bezos worth? He's currently the richest person on the planet. He cracked 100 billion a while ago. So this is 700 million that we started out with. Try spending 100 billion, and that's just an unheard of amount of cash. So I got 91.4 years. Why is the pen vanishing here? Oh, it wasn't vanishing. The screen was frozen. 91.4 years. Next page. Put your pencils down, look up. Enrico Fermi, one of my nerd heroes, was a physicist who would often ask his students to solve a problem by making reasonable assumptions about unknown data. He was famous for being able to do incredibly complicated calculations in his head and giving you a ballpark figure after about 19 steps of calculating, and his ballpark figure was almost always pretty close. In fact, he was part of the team that developed the first atom bomb at what was then called the Manhattan Project. And when the first atom bomb went off, he held a piece of paper, and as the shock wave hit him, he let the piece of paper go, and by estimating how far back it went, very quickly in his head, he gave a ballpark figure for how big the bomb was, and he was darn close, it turns out. He was just very, very good at that. We've started to call these Fermi problems. They're named after him. The idea is to provide a reasonable mathematical argument for your answer so that you feel that your answer was within an order of magnitude. What does within an order of magnitude mean? It means if you wrote it in scientific notation, Chad, the 10 to the was correct. I think it's around 10 to the 4th. Could be 9 times 10 to the 4th, could be 3 times 10 to the 4th. I don't care about that, but I bet you the answer is around 10 to the 4th. It says, try the following two Fermi problems. First of all, I have a video to show you, so put your pencils down. So the idea behind a Fermi estimation is you make educated guesses, and this is going to be part of your homework. I'm not going to mark this. I'm not going to collect this. I'm not going to grade you on this. But I'm curious. Let's change the number a little bit here because our numbers are down a bit. If Pitt Meadow Secondary has 1,000 students, nice round number, how many pieces of note paper does the entire student body use in an average year? Convince me with a good mathematical argument. That's Fermi question number 1. Fermi question number 2. How many bricks make up the outside of our school? Can you give me a good estimate without leaving the classroom? And all I'm looking for, again, here is can you give me a mathematically convincing argument, Caleb? Can you give me an argument where I say, you know, I buy that. I don't think you made any guesses that are too big or too small. Again, I'm not going to grade or assess those. That's not your official homework. Here's your official homework. Let me pause. Take a look at the sheet that I just gave you, please. It's called Conversions. You can do this right on the sheet if you write small. If you want to do something on a separate piece of paper, you can. Number one, these are one-step conversions. You're just replacing the metric prefix. Number two, these are two-step conversions. Number three, some more two-step conversions. Number four, these are conversions where you're having to convert more than one thing. Oh, I'm going to have to convert kilometers to meters and hours to seconds. So it's multi-step. Turn the page over. Look at the back, please. Number 5 says this. Turn the page over and look at the back, please. I made them up. If 50 wubbas equal 20 yontas, and 40 yontas equal 10 zappas, and 8 zappas equal 9 migliks, how many migliks are 20 wubbas equal to? What you want to start out doing first of all is write down what they gave you, which is 20 wubbas, although I might abbreviate wubbas with which letter? W. I tried to pick different letters on purpose so you can abbreviate. Start with 20W. There are enough conversion factors hidden in that sentence that you can build a chain to turn something into something, into something, into something, into something, into something, into something. I like that question. I like that question. I like that question. That question is a nice question. Why would I say that? Really? No hints there? Okay. You might see it in the future sometime. Number 6, how many minutes are in a decade? What is a decade? If you can do that conversion in your head, you can start out right away writing 10 years. You don't have to write down 1 decade. If you feel comfortable, Chad, I know that's 10 years. 10 years. And then write down what they gave you. 10 years, convert that into minutes. How long will it take you to count to 1 billion, counting one number every second? So 1 billion seconds is what you'll write down. Convert that to hours. Then convert that to days. Convert that to years. Can you count to 1 billion in your lifetime? Is it humanly possible? That's kind of what I'm wondering. Have you never wondered these questions? How high could I count if I never stopped counting before I died? I'm the only one? Okay. Number 8. Convert 365. What's a capital P? Peta? Oh, petameters per kilosecond to micrometers per millisecond. I like that question. I like that question. I like that question. Why would I say that? Oh, you're the kind of student that tends to notice when your teacher emphasizes certain things and you realize that might be on an upcoming test or quiz? Good, 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 good. You'll be okay. Good, 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 good. If you finish that in class today, check your answers. I'm going to print up a couple of answer keys. I'll have them up here. Don't walk off with them. I'm also going to put the answers online. And then you can also try the 2 Fermi questions. Okay?